ठीक है. Okay, in 5.5, entropy, Gibbs, and spontaneity of the processes is covered. Look at the eighth one. For a reaction, A gaseous in equilibrium with B gaseous. At equilibrium, the partial pressure of B is found to be 1/4 of partial pressure of A. The value of delta G naught for the reaction A to B, it's reversible only over there. Delta G naught, how would you find for an equilibrium reaction?
minus 2.303 RT locally based on K.
Now options mein they are not asking the values, they are just asking the ln form. So I'll just write minus RT ln of Kp. Yes.
Yes, sir.
Now for equilibrium, the equilibrium constant for this is found as partial pressure of B upon partial pressure of A,
Yes, sir.
and that is already given as 1/4. So simply put the value, it will be minus RT ln of 1/4, and minus को अगर अंदर ले ले तो it will be plus RT ln of 4. Clear?
Yes, sir.
So for an equilibrium reaction, delta G naught is minus 2.303 RT log of Kp to the base 10, या ln के फॉर्म में minus RT ln Kp. This is the equilibrium constant. Here the partial pressures were directly given. In case they are not given directly, then in the chemical equilibrium, we have learned how to find the partial pressures and then take the ratio to find the equilibrium constant. How would the partial pressure be found?
Moles, uh, mole fraction into the total given pressure.
Perfect. Mole fraction of B into the total pressure. Similarly, partial pressure of A would be mole fraction of A into the total pressure. This is how it would be found. Clear?
Yes, sir.
Okay. 12th one. When 2 mole of an ideal gas with Cp equal to 5/2 R, 5/2 R Cp refers to
Diatom.
diatomic gas. So it's
Yes, sir.
heated from 300 to 600 Kelvin at constant pressure. The change in entropy of gas is. So we have talked about entropy change for various processes. Here the process is at constant pressure, meaning it's isobaric. What was delta S equal to? Entropy for isobaric, entropy change. I've talked about all the 4
And
processes, na? Huh.
yeah, NCP ln T2 by T1.
Perfect. See, isobaric is NCP ln of T2 by T1. Isochoric,
CV.
NCB ln T2 by T1. Isothermal is W max divided by T.
NR
So
ln V2
NR
by
ln
V1.
V2 by V1.
Yes,
And adiabatic, the entropy changes
0.
0. हो गया चारों केस.
Yes.
So it is N into Cp into ln of T2 by T1. The number of moles are 2, Cp is 5/2 R, and ln of 600 by 300, that is 2. So this will be 5 R ln 2. Option C. Clear?
Yes.
13th, for a reaction A gaseous at 1 bar plus half B2 gaseous 25 bar pressure, giving you AB gaseous. What is the initial free energy change? Initial free energy change. If you look at the values, delta G is plus infinity, delta G is 0, delta G is minus infinity, and delta G cannot be determined. Now, to get the free energy change and a reaction is at equilibrium, what is the pressure of the product at the start, initially?
0.
1. 1 bar.
Initially, at
Oh,
time t equal to,
product. 0.
0.
this is
Hmm.
already given कि इसका 1 बार है, इसका 25 बार है, but this will be equal to 0.
0.
So initial बोला है, इसका मतलब what will be the equilibrium constant initially?
0.
Yes.
Equilibrium constant would be 0 because it's a partial pressure of products upon the reactants raised to the power, so it is 0.
Yes, sir.
So if I apply the formula in which I have ln of k equilibrium, what do I get?
Not defined.
Undefined. बराबर. So
Yes, sir.
basically it will become ln of 0. So if it is undefined, then delta G should be, the answer should be cannot be determined because it is undefined. ठीक है. But still, rationally, whenever we talk about the ln of 0 part, to make it calculative, the ln of 0 is taken as infinity. The ln of 0 will be taken as infinity. ठीक है. It is undefined definitely, but rationally जब calculate करते हैं तो ln of 0 could be taken as infinity. Okay.
Yes, sir.
So in this case, if I talk about delta G, it's equal to delta G naught plus RT ln of Q. But equilibrium जब होता है तो delta G 0 हो जाएगा. Yes or no? Now,
Yes, sir.
Yes, sir.
there are a lot of confusions in the question which is asked. Because if they talk about the initial free energy change, equilibrium पे, whether it is initial or final, delta G is taken to be
0.
0 only. क्योंकि डेल्टा जी 0 होगा तभी तो इक्विलिब्रियम पे वी गेट डेल्टा जी नॉट एज माइनस आर टी एल एन ऑफ के. अब अगर मैं के को 0 डालकर यहाँ पे देखो तो इट इज माइनस इन्फिनिटी. So if they had talked about the standard free energy change at the initial stage, it should be minus infinity. If they are talking about just free energy change, it should be equal to 0 and cannot be defined sort of correct होना चाहिए. But they have just defined the ln of 0 as infinity and then minus infinity का आंसर दिया है. तो थोड़ा वेग क्वेश्चन है मेरे हिसाब से. स्टिल अगर ऐसा कुछ सिनेरियो आ जाता है तो आई जस्ट डिस्कस दैट फ्री एनर्जी चेंज इनिशियल लेवल पे अगर डेल्टा जी नॉन स्टैंडर्ड कंडीशन पूछा है तो जीरो ही होगा बिकॉज इट इज द कंडीशन ऑफ इक्विलिब्रियम इटसेल्फ. ओके.
Yes, sir.
Yes.
ठीक है. ओके. मल्टीपल में 14th वन. For an ideal gas, consider only PV work in going from initial state X to the final state Y. So there is a PV diagram given, P in atmosphere versus volume in liters. The initial point is X and it is going to final state Z via Y. The final state Z can be reached by either of the two paths as shown in figure. It can be X to Y, Y to Z, or directly from X to Z. So there are two paths. So which of the following are correct? Take delta S as change in entropy and W as the work done. So it's simple, just understand. First part mein they are saying delta S, the entropy change for X to Z is equal to the entropy change X to Y and Y to Z. Should it be correct?
Yes, sir.
Why?
Because entropy is a state function, so it doesn't depend on the path.
Correct. Entropy is a state function. State function matlab it just depend on the initial and the final state, doesn't depend on the path. So whether you go from X to Y, Y to Z, or from X to Z, the entropy change is going to be same. So that's valid. W from X to Z, will it be equal to W X to Y and Y to Z?
No.
No, because in this case it is path dependent, no?
Path. Yes, sir.
Work is a path function, so it will depend on the path. So X to Y, Y to Z, and X to Z में work done different आएगा, मतलब this is false. Then W of X to Y, Y to Z, is it equal to W of X to Y?
Hmm.
हाँ
Yes, sir.
Why?
Yes, sir. Because isochronic, no, YZ. So that be zero either.
Zero.
YZ जो है वो तो आपका आइसोकोरिक हो गया. So जो पूरा पाथ का
Zero.
वर्क है वो XY के बराबर ही होगा. That's correct. And D में delta S of X to Y to Z is equal to delta S of X to Y.
Wrong.
No.
Now this can't be correct. So ये incorrect. Option A and C should be the answer. Okay.
Yes, sir.
Yes, sir.
Okay. 17 जो है ना, you can just cancel off this because it's based on Euler's reciprocity theorem, which you don't have in the syllabus. So just cancel off that. पीछे भी एक क्वेश्चन पैसेज में है, आई जस्ट डिस्कस दैट. उसमें भी एक पार्ट है जो आपको नहीं है, यूलर्स वाला पार्ट. सो डोंट वरी अबाउट दैट. ओके.
Yes, sir.
Yes, sir.
ओके. 18th ऐसे क्वेश्चंस काफ़ी बार पूछे गए हैं. 18th इट्स सिंपल. इन विच ऑफ द फॉलोइंग एंट्रोपी इंक्रीजेस? रस्टिंग ऑफ आयन,
No.
रस्टिंग ऑफ आयन में
Decrease.
the Fe is changed to Fe2O, and it is actually the combustion kind of oxidation reaction in the presence of moist air. So if you look at the gaseous moles, they are actually going on. क्या होगा? Hello.
Yes, sir.
What happens in corrosion is Fe burns in oxygen in the presence of moisture to form Fe2O3 dot XH2O. So if you look at this reaction, the gaseous moles on the left are present and on the right it is completely converted into solid. So what happens to
Yes.
the entropy?
Negative.
It is decreasing. The
Yes,
entropy
sir.
for rusting is negative. ठीक है, तो ऑप्शन ए रूल्ड आउट है. Vaporization of camphor, sublimable substance, entropy will
Increase.
of course increase. Crystallization of sugar from syrup,
So decrease, no?
decrease, because there is a liquid form of the syrup which is getting converted into
Yes.
crystalline solid. And atomization of dihydrogen,
Increase.
Increases.
so H2 gaseous when breaks down, it gives 2H gaseous. So moles of gas are increasing, matlab entropy is also increasing. Okay.
Yes, sir.
Now 20th mein there is some problem because all the graphs are given as G versus P, and still A and C are given to be correct. For the same relation, how the two graphs could be same? There should be some different things plotted on the x and y axis. ठीक है, इसमें भी कुछ गड़बड़ है. अच्छा, just if we talk about G versus P का relation, G versus P, Gibbs energy versus the pressure. How does it, how is it related rather? G and P का क्या relation है?
Directly proportional.
It is directly proportional. Gibbs energy is the free energy change, and for the gaseous components, the Gibbs energy is large, and as the entropy goes on decreasing, the Gibbs energy for the lower entropy substances also decreases. तो जितना डिसऑर्डर्डनेस रैंडमनेस ज़्यादा होगा उतना गिब्स एनर्जी भी ज़्यादा रहेगा, एंड दैट इज फॉर द गैसियस सब्सटेंसेस. सो जी वर्सेस पी में विच ग्राफ इज लॉजिकली करेक्ट?
A.
The
All
first,
is all are increasing. So,
all are increasing and gas is at the higher.
yes, sir.
Okay, so one of the option is A. बाकी में गड़बड़ है. Okay.
Yes, sir. So more the disorderness, more the gives the energy, right?
Yes, because more work can be done, na? So the useful work
Yes.
is the Gibbs energy change. तो यूजफुल वर्क ज़्यादा किस में होगा? व्हेन देयर इज गैसियस सब्सटेंसेस इन्वॉल्व.
Okay, sir.
सॉलिड्स और लिक्विड्स में इतना नहीं होता है, इसीलिए तो वी जस्ट टॉक अबाउट द गैसियस कंपोनेंट्स बिकॉज दैट हैव द टेंडेंसी टू हैव द appreciable volume change and the pressure change. That's why the work could be calculated in terms of pressure volume work.
Yes, sir.
Okay, now come to passage 2. Passage 2. Here there are different state functions which are given and their definitions are given. पहले डेटा देख लेते हैं. G is H minus Ts, gives energy. H is equal to U plus PV, that's enthalpy. A is equal to U minus Ts. Now A is called Gibbs Helmholtz energy या free energy. जो गिब्स एनर्जी है दैट इज H माइनस Ts, मतलब डिपेंडेंट ऑन एंथैल्पी एंड एंट्रोपी. बट व्हेन यू राइट दिस रिलेशन इन टर्म्स ऑफ इंटरनल एनर्जी एंड एंट्रोपी, देन इट इज कॉल्ड गिब्स हेल्महोल्ट्ज फ्री एनर्जी. ठीक है, जो ज़्यादातर यूज़ करते हैं दैट इज दिस पर्टिकुलर रिलेशन ऑफ H माइनस Ts. Okay, but just remember that whenever A is given, is it's Gibbs Helmholtz free energy. Then dq is equal to TdS, that is entropy is Q reversible upon T, well known hai. And du is equal to dq minus pdv, this comes from first law of thermodynamics, right?
Yes, sir.
अब 27th question में which of the following relations is are correct? And if you look at the relations, they have asked to verify delta G by delta T at a constant pressure, is it equal to minus S or not? Similarly, not delta rather, it's del G by del P at a constant temperature is equal to V. So for the infinitesimal changes, we have to relate this change of Gibbs energy with respect to temperature at a constant pressure. तो ideally ऐसे questions में approach क्या रहेगा? We want to get the differential form for Gibbs energy. So I'll start with H minus Ts. ठीक है? Yes.
Yes,
Yes,
sir.
sir.
Now I want the relation with respect to temperature and with respect to pressure. So यहाँ पर temperature वाला part तो है but pressure वाला part नहीं है. So what I can substitute over here?
T.
Huh?
Substitute T, no?
T as what?
Um, PV upon NR.
PV upon NR.
PV upon NR. And what else? There are these relations already given. See,
So H to substitute.
H को substitute कर सकते because H will give you the internal energy and the PV relation both. ठीक है? तो यहाँ पर H की जगह U plus PV और minus TS. अब yes. Now if I take the differential form, tell me what will be the differential form? dg or del G is, बोलो.
Du by dt.
We are differentiating with respect to the temperature only, so यहाँ पे just आप del G लिख सकते हो, which will be del U plus, इसको कैसे करेंगे? UV rule,
UV. P delta U. Delta V.
P del V plus
Del PV.
V delta P.
V del P
Hmm.
minus similarly TS, UV rule लगाओ,
S.
S delta T.
P
Hmm.
del S minus S del T. Okay,
Hmm.
clear?
Yes,
Yes,
sir.
sir.
Now can you substitute something as per the data given in place of the variables which we are getting?
T delta S.
T delta S, what's that?
Delta
DQ.
G minus delta. Hmm.
Uh-huh,
DQ.
DQ, DQ.
dq है वो, and du की
DU.
जगह I can write
Delta Q minus PdV.
dq minus pdv, pdv gone, this dq and this dq also gone. Yes,
Yes, sir.
मतलब डेटा के हिसाब से we started with G, we replaced H, and we just found out the dq and du variables over here. तो जो भी डेटा दिया है we are just supposed to use that. ठीक है, तो इससे क्या आया? dg is equal to vdp minus sdt. Yes.
Yes, sir.
Yes, sir.
Now if I take this at a constant temperature, what will happen?
T0.
dt 0 हो जाएगा, मतलब this term will be gone.
Yes, sir.
So at constant temperature, can I say dg equal to vdp?
Yeah.
Therefore, can I say dg upon dp is equal to v at a constant temperature? Yes.
Yes, sir.
Similarly, अगर मैं dp के हिसाब से I take the constant pressure, then this term will go away. So dg will become minus s dt at a constant pressure, and therefore dg upon dt at a constant pressure, is it equal to minus s?
Yes, sir.
So finally, which of the following relations were correct? In case of 27, both A and B are correct. So answer is C. समझा? तो ये relations prove करने के लिए you start with the state functions, take the differential form, and whatever differential forms are given in the data, just try to substitute over there. And then जो भी relation आता है उसके basis पे whatever conditions they have asked, constant temperature and constant pressure, you just make dt and dp 0 respectively and you get the relation. समझा?
Yes, sir.
Similarly पहले 29 देखो. अब 29 में they have asked you to find the differential forms of A. तो start कैसे करेंगे?
A is U minus TS.
Next,
Differential
Derivative.
with respect to T.
and कुछ substitute कर सकते हैं यहाँ पर.
du and T delta ds.
So we take dA equal to du minus t ds minus s dt. du की जगह
DQ minus PdV.
and this will be
DQ.
dq and s dt. Gone. So we get minus t dv minus s dt. Similar form आ गया ऐसा.
Yes, sir.
तो अब if I take the constant temperature, so dA by dV will become equal to minus P at a constant temperature, and dA by constant volume अगर लूँ तो dA by dt
Minus
equal to
S.
minus S at constant volume. समझा relations कैसे निकालना है?
Yes, sir.
Yes, sir.
So 29 में ऑप्शन A and B तो करेक्ट मिल गया. C वाला जो है that is something again related to Euler's reciprocity theorem. तो आपको अगेन सिलेबस में नहीं है और 28th क्वेश्चन भी उसी से रिलेटेड है. सो यू कैन कैंसिल ऑफ 28, बट 29 में दो तो रिलेशन प्रूव कर सकते हैं, तो आंसर ऑल ऑफ दिस हो जाएगा. ओके.
Yes.
ओके, पैसेज 3 में ग्राफिकल रिलेशन जो है ना, जस्ट ट्राई टू सॉल्व इट ओरली. देयर इज एंट्रोपी चेंज ऑफ एन आइडियल गैस गिवन बाय n into Cv ln T2 by T1 plus R ln V2 by V1. Now this is the general form of entropy change. एक जनरल फॉर्म है एंट्रोपी चेंज का, और ये प्रूव भी किया जा सकता है. इनफैक्ट जो 4 केसेस मैंने बताए हैं, इट इज़ लाइक द जनरल एंट्रोपी चेंज डिफाइंड. ओके. सो व्हेन वी डिस्कस्ड अबाउट एंट्रोपी चेंज फॉर वेरियस प्रोसेसेस, ठीक है, हाउ डू वी राइट एंट्रोपी? डी एस इक्वल टू डेल्टा एस. क्या लिखते हैं?
NCP.
डेल्टा एस. एन सी पी, एन सी बी अलग अलग केसेस के लिए अलग है. सबसे बेसिक डेफिनेशन स्टार्ट करो. व्हाट इज एंट्रोपी चेंज? What is the
It's
unit?
like
What is unit of entropy? अरे एंट्रोपी का यूनिट क्या है? Look at the options given in 26.
Joule per Kelvin.
So what is entropy defined as? Why do we get joule per Kelvin?
Heat, heat capacity. dq by
T by
dt.
T.
Entropy is
Hmm.
defined as the heat transferred in a reversible process to the absolute temperature in Kelvin. So that's the reason entropy is joule per Kelvin, and if it is for per mole, then joule per Kelvin per mole आता है. ठीक है. अब we know that du is equal to dq plus w या q plus w. Yes,
Yes, sir.
Yes, sir.
and w is minus p into dv.
Yes, sir.
ठीक है. तो अब एंट्रोपी चेंज for infinitesimal changes is dq minus, sorry, d, from here dq will become equal to du plus pdv. Yes or no?
Yes, sir.
So ds की जगह I can sorry dq की जगह I can write du plus pdv upon t. Now what is du or delta u? How do we write delta u?
Q, QP, no? Oh, that way.
qv, it's qv.
Yeah. Q, yeah, yes,
ncv,
sir.
ncv
Delta T.
delta t. So for smaller change, I can write ncv dt, yes or no,
Yes, sir.
अपॉन t. इसके लिए ले लेता हूँ. ठीक है, प्लस p dv by t. Now we are talking this with regards to an ideal gas. So for an ideal gas, pv is equal to nRT. So p by t will become equal to nr by v.
Yes, sir.
Correct. Now just get the entropy change by integrating ds from 1 to 2, initial to final state. Now this will give you delta S, and if I apply the integration over here, ncv being a constant, what is integration dt by t?
Minus.
इंटीग्रेशन dt by t.
Um,
क्या हो गया है भाई? इंटीग्रेशन dx by x
minus T, minus T.
minus t.
One.
इंटीग्रेशन dx by x
Log X.
ln mod x to the base e.
Yeah.
Tangshi,
Yes, sir.
forgot integration of what?
Yes, sir.
So it's ncv ln of t, and temperature initial to final अगर अप्लाई करेंगे तो ncv ln t2 by t1 आएगा, plus this will be nr ln v2 by v1. Just look at the given data now. Delta S is n common cv ln t2 by t1 plus r ln v2 by v1. And if you substitute v की जगह cp minus r, you will get the other relation which is given. समझा?
Yes, sir.
Yes, sir.
So अब देखो, अगर हम चार केसेस को वापस लेते quickly, isothermal, what is going to go off?
T2 by T1.
Because isothermal में temperatures equal है, so this will become ln1 is 0, ये term उड़ गया. What was the entropy change for isothermal? Hadn't we written nr ln v2 by v1?
Yes, sir.
So isothermal के बाद isocoric, कौन सा term उड़ जाएगा?
V2 by V1.
So was delta S ncv ln of t2 by t1.
Yes, sir.
Then isobaric, we had written ncp ln of t2 by t1.
Hmm.
तो इस CV को if you change in terms of CP, see the other relation is already given. N CP ln T2 by T1 plus R ln P1 by P2. तो आइसोबारिक में P1 इक्वल टू P2 हो जाएगा. तो सेकेंड टर्म उड़ने के बाद अपने को मिलता है कि नहीं, N CP ln T2 by T1.
Yes, sir.
Yes.
एंड ए डायबिटिक के लिए
Q.
0.
सीधा Q ही 0 हो जाता है. सो डेल्टा S इज इक्वल टू 0. ठीक है. सो दैट इज
Yes,
व्हाट
sir.
द जनरल रिलेशन इज. अब क्वेश्चन है, द स्टैंडर्ड मोलर एंट्रोपी ऑफ एन आइडियल गैस is the entropy of 1 mole of an ideal gas at 1 bar pressure and at definite temperature. SM stands for molar entropy of an ideal gas at a pressure of P bar. तो अब पूछा है, which of the following figure represents a variation of SM minus SM naught versus P in bar. मतलब बेसिकली डेल्टा S वर्सेस P पूछा है. यस, ऐसा
Yes,
नो.
sir. Yes, sir.
तो प्रेशर के टर्म्स में आई कैन टेक द रिलेशन एज गिवन एन सी पी एल एन टी टू बाई टी वन प्लस एन आर एल एन पी टू बाई पी वन. इज दैट ओके?
Yes, sir.
Now if you look at the statement again, the standard molar entropy is the entropy of 1 mole of an ideal gas at 1 bar pressure. What is this 1 bar equal to? 1 bar will be equal to which pressure?
P1.
Its initial pressure P1 and
Yes,
at
sir.
definite temperature. Definite मतलब क्या?
Constant, ना temperature.
कांस्टेंट टेम्परेचर. मतलब T1 और T2 इक्वल हो जाएगा. मतलब दिस टर्म विल गो अवे एंड फ्रॉम द सेकेंड टर्म द डेल्टा S इज इक्वल टू एन आर एल एन ऑफ P2. Sorry, it is P1 by P2. Sorry, it is P1 by P2. So this will become 1 by P2. Yeah.
Yes, sir.
So it is minus nr ln of the final pressure. So if you plot the graph of delta S versus ln of P, what type of graph you will get?
Straight line with decreasing slope. Like
Line with a
incline.
decreasing slope.
Yes,
So
sir.
which is the correct graph?
It's option D.
Option
D.
B or D?
D.
Hmm. So बाकी के लिए the curves are given. So obviously this is for the linear graph and positive slope नहीं है, negative slope है. तो correct answer D है. Okay.
Yes, sir.
ठीक है. तो बस ये ग्राफिकल रिलेशन इंपॉर्टेंट था. The shortcuts on the tablet are not working. Writing tablet. पता नहीं आज क्या है. Okay. Now 5.6 में heat capacity and calorimetry से questions. Question 7. बहुत अच्छा क्वेश्चन है. The question is 4 kilogram of ice. There is ice of 4 kilogram at minus 20 degrees Celsius is mixed with 10 kilogram of water which was at a temperature of 20 degrees Celsius in an insulating vessel having a negligible heat capacity. So heat capacity को ignore करना है and the mixing was done in an insulating vessel. Calculate the final mass of water remaining in the container. 4 किलोग्राम आइस को 10 किलोग्राम वाटर से ऐड किया. अब ऐड करने के बाद what will be the final mass of water in the container? Specific heat capacities of water and ice are given, and molar enthalpy of fusion of ice is given. Logically, when you mix the ice with water, where ice is at a minus 20 degrees Celsius and water is at 20 degrees Celsius, the final mass of water is going to be कितना होना चाहिए?
More than 10 kg.
More than 10 kg. So option A and B तो definitely आप rule out कर सकते हो. 50-50 हो गया.
Yes,
Yes?
sir. Yes, sir.
Okay. After the melting of ice, will the 4 kg and 10 kg add up to give you 14 kg?
No.
नहीं होगा. There will be some lost
Yes, sir.
because second law of thermodynamics क्या बोलता है?
No machine gives you 100% efficiency.
No machine gives you 100% of efficiency. मतलब पूरा heat work में convert करना impossible है. So what is the logical answer?
C.
ऑप्शन सी. ठीक है, ये तो हो गया शॉर्टकट. अब मान लो आपको सॉल्व करना है तो कैसे करें? आंसर क्लियर है पहले तो?
Yes,
Yes,
sir.
sir.
अभी 12 kg अगर लाना है तो इसका अप्रोच क्या होना चाहिए? मान लो आपको 11.5, 12 और 13.5 ऐसे ऑप्शंस दिए होते हैं तो फिर डेफिनेटली लॉजिकली आंसर आप नहीं बता पाते हैं. तो इन दैट केस क्या करेंगे? व्हाट विल बी द प्रोसेसेस बाय विच द आइस वुड कन्वर्ट टू वाटर? क्या क्या स्टेप्स होंगे? यू हैव डन दिस टाइप ऑफ क्वेश्चन इन द न्यूमेरिकल्स, है ना? याद है वहाँ पे
Yes.
वेपराइजेशन तक लेकर गए थे हम लोग.
Yes, sir.
Ice to water and water to water vapor. So firstly, the ice at minus 20 degrees Celsius will be converted to
I said 0 degrees.
ice at 0 degree. Very good.
Yes, sir.
Then ice will be in equilibrium with
Water at 0
Water.
degrees.
water at 0 degrees Celsius. And this water would change to water at a higher temperature, that is 20 degrees Celsius.
Yes, sir.
For this, what will you apply?
MC delta T.
NC delta T. For this conversion,
Latent heat of fusion.
latent heat of fusion, and for this
NC delta T.
NC delta T. बराबर.
Yes, sir.
अब just also observe the specific heat of ice is given in what unit? 2.092. पहले water दिया है. C of water कितना है? 4.184. Obviously water का तो ये standard value है. Just look at the unit. It's kilojoule it's kilojoule per Kelvin per kilogram per kg दिया हुआ है ना? और अपने को वैसे भी मास में ही बात करना है, so direct multiplication is okay ना?
Yeah.
Yes, sir.
So initially ice के लिए I will write MiCi into how much is the change?
20.
20.
20. Then delta H of the fusion, it's given as 337.7 kilojoule per kg. तो आपको ये वाला आइस कितना वाटर में कन्वर्ट हुआ है, हाउ मच मास इज कन्वर्टेड, वही तो फाइंड करना है,
Yeah.
Yes, sir.
सो दैट यू कैन फाइंड द टोटल वाटर प्रेजेंट.
Yes, sir.
ठीक है. अच्छा, मेल्ट जब हो रहा है, ठीक है, तो दैट हीट इज प्रोवाइडेड बाय विच पर्टिकुलर प्रोसेस? देयर इज एन इंसुलेटिंग वेसल ना, इंसुलेटिंग वेसल है, तो हीट सिस्टम और सराउंडिंग में तो एक्सचेंज नहीं हो सकता ना,
No.
Yes, sir.
तो सिस्टम के अंदर से ही कहीं पे हीट आ रहा है, सो
Mm.
फ्रॉम वेयर इट
Yes,
इज,
sir.
फ्रॉम वेयर इट इज प्रोवाइडेड,
Water to ice.
दिस वाटर इज प्रेजेंट एट 20 डिग्री सेल्सियस, सो ये
Yes,
वाला
sir.
हीट इज प्रोवाइडेड फॉर द आइस टू मेल्ट. So as per law of conservation for the insulating vessel, the heat which is absorbed for this process is equal to heat which is released by this process. Yes.
Yes, sir.
Yeah.
मतलब इन दो प्रोसेसेस के लिए जो हीट एब्जॉर्ब हो रहा है वो इस पर्टिकुलर प्रोसेस का हीट रिलीज की वजह से मिल रहा है. करेक्ट.
Yes, sir.
सो m डैश यही अपने को फाइंड करना है इनटू 334.7 and this should be equal to mwcw into, again the difference is same, 20. Now this is 4 kilogram, this ci is given, this is 10 kilogram, this cw is given. From that you can find out m dash. Correct.
So when we're talking about heat being released, we're saying that from water at 20 degrees Celsius to water at zero, right? That is when heat will be released.
हाँ, so ये प्रोसेस के लिए ही बोल रहा हूँ ना,
Oh,
एनसीवी डेल्टा टी वाला रिलेशन.
okay, sir.
So that heat will be negative and this heat will be positive for the overall process of fusion as well as this latent heat का concept, right?
Yes, sir.
तो या तो आप इसको नेगेटिव लेकर इक्वल टू जीरो कर लो या फिर लॉ ऑफ कंजर्वेशन को अप्लाई करके दोनों को इक्वेट कर लो. इधर वेज इट सेम.
Okay, sir.
ओके.
Yes, sir.
ठीक है. एथ वन, ice water mass ratio is maintained at 1:1 in a given system containing water in equilibrium with ice at a constant pressure. If Cp of ice is equal to Cp of water, and that's equal to 4.18 joule per mole per Kelvin, molar heat capacity of such a system is. When you say ice and water are in equilibrium, so this process is at a constant what?
Temperature.
At a constant temperature.
Hmm.
Isothermal बोल सकते हैं.
Yes, sir.
ठीक है. It's at 0 degree Celsius 273 Kelvin. Fusion process is always at a standard constant temperature, right?
Yes, sir.
So now if I want to relate the heat capacity of this system, what relation I would think?
Latent heat.
Latent heat क्या लिखेंगे?
Mass into the value of latent heat of fusion.
Just tell me the formula.
M into L.
N into, यहाँ पे अप्लाई किया ना हमने. When you take moles, it's molar heat capacity into the difference of temperature, right?
Yes, sir.
So this is the enthalpy for this particular process, यानी enthalpy of fusion ही है ना ये, NCP delta T.
Yes, sir.
Now for this equilibrium processes, अगर temperature constant है, so what is delta T?
Zero.
So if delta T is 0, what is Cp?
Zero.
Cp will be equal to delta H upon N delta T. Yes or no?
Yes, sir. Yes, sir.
एंथैल्पी ऑफ फ्यूजन तो नॉन जीरो है, मोल्स भी नॉन जीरो है. अगर डेल्टा टी ही जीरो है तो सीपी क्या होगा?
Infinity.
Yes, Cp will be infinite. Molar heat capacity of such a system is infinity. It means what? The amount of heat required to raise the temperature by 1 Kelvin under this condition of constant temperature, isothermal condition, is going to be very,
Very high.
got it?
Yes, sir.
Okay. ठीक है, आगे सब सिमिलर टाइप के क्वेश्चंस है ना। 11th वाला देख लो। For the hypothetical reaction of A2 plus B2 giving twice AB, if delta G naught and delta S naught are respectively given at 200 Kelvin, delta Cp is 20 joule per Kelvin per mole, then delta H naught at 400 Kelvin is delta H at 400 Kelvin. What relation you will use?
Delta G is delta H
Delta H
minus
minus
T
T
delta
delta S.
S.
Delta G naught is equal to delta H naught minus T delta S naught. Delta G naught, delta S naught और temperature 200 Kelvin दिया है. So from here we'll get the delta H naught at 200 Kelvin. But question is delta H naught at 400 Kelvin क्या होगा? ये तो मिल गया फर्स्ट स्टेप से, बट आपसे पूछा गया 400 पे कितना? How would you solve? If you want to compare the two enthalpies at different temperature, which relation do you use?
Delta C
हाँ,
P2 minus
कौन सा?
CP.
Speak louder, please. अरे, there was a relation ना wherein the enthalpies at
Delta H is equal to NCP delta T.
नहीं, वो तो आपको एक पर्टिकुलर
Okay, so yes, sir.
टेम्परेचर के लिए, टेम्परेचर डिफरेंस के लिए देगा ना.
Yes, sir.
Kirchhoff's equation gives you the enthalpy change
Hmm.
at two different temperature, and the relation was delta H2 minus delta 1 is equal to delta
Delta
Cp.
CP
CP T2 minus
T2
T1.
minus T1.
याद रखो, when you are comparing the enthalpies at two different temperatures with the change in the heat capacity is given, then you can use the Kirchhoff's equation. तो ये आपको ढूंढना है. Delta H1 at 200 Kelvin is found, difference is 200, and delta Cp is given. Understood?
Yes, sir.
Look at 14th one now. 14th में which of the following statements are correct पूछा है. First one, the value of Cp by Cv for a mixture of 1 mole of a monoatomic gas gamma equal to 5 by 3 and 1 mole of a diatomic gas gamma 7 by 5 is 1.5. Cp by Cv का ratio for mixture of 1 mole of a monoatomic gas and 1 mole of a diatomic gas. तो prove करना है is it 1.5 or not. अच्छा, when you have a mixture of the gases, how do you find the Cp? Mixture of gases के लिए how do you find the mole fraction?
Half delta C.
It will be half
Delta C.
delta C. So basically you're using the mole fraction का concept. So Cp for a mixture will be equal to moles of the first gas into Cp of the first gas plus moles of the second gas into Cp of the second gas upon the total moles. Now half Cp कब आता जब Cp values दोनों के लिए similar होता ना. Here we are talking about mixture of a monoatomic gas and mixture of a diatomic gas जिसका Cp values are different. Moles same है, right? Sujal. Hello.
Yes, sir.
हाँ. So Cp of the mixture आप find कर सकते हो. मतलब you will take moles as 1 and Cp values for the mono and diatomic gases. You know. So it will be 1 into what is Cp for the monoatomic gas?
5/3.
Huh?
5/3.
5/3.
5/2 R. R होता है ना?
Yes, sir.
Yeah.
Plus 1 into Cp for diatomic gases
7/2.
and the total moles are 2. ठीक है. Similarly Cv for the mixture आप find कर लो. That will be 1 into 3/2 R plus 1 into
5/2. 5/2.
5/2 R and upon 2. Clear है?
Yes, sir.
तो R cancel off हो जाएगा. Now when you take the Cp by Cv का ratio, it comes out to be 1.5. तो याद रखो mixture of the gases with different atomicity अगर आपको Cp Cv find करना है, it's simply the mole fraction वाला concept which is applied over here. Clear?
Yes, sir.
Yes, sir.
Okay, so A option correct. Up B. The work done by an ideal gas in expanding V1 to V2 is higher when the expansion is done isothermally as compared to that carried out adiabatically. Work of expansion isothermal के लिए large होता है as compared to adiabatic. True or false? अच्छा, let's understand this graphically. If I have the PV diagram for isothermal and adiabatic, what is the difference in the curves?
The adiabatic curve is like a rectangular hyperbola, like steeper.
Steeper. So if I draw the two curves, which is the first one
Isothermal.
and second is adiabatic.
Adiabatic.
Now if I want to talk about expansion, so if this is the initial point and these are the final points, let's say B and C, then expansion में the volume increases, so the arrow will be from A to B and A to C. यही चीज अगर compression में करते तो arrow would have been reversed. Okay.
Yes, sir.
Now for this particular process, if I want to get the work done, then just take area under the curve. So area under the curve अगर लेते हैं तो work for the isothermal and work versus adiabatic, what is the comparison?
Work of isothermal is greater.
Work for isothermal is greater, but it comes with a condition. If I am writing greater,
Mod.
huh? What?
Mod. Mod sign, na?
We are talking about the magnitude over here because work of expansion तो negative होता है ना. The magnitude of the work done in the isothermal is definitely greater than the magnitude of the work done in adiabatic. ये clear है?
Yes, sir.
मतलब मान लो आपका isothermal work जो है वो -200 है और adiabatic उससे कम होगा -150. So if we are not comparing with the mod, then work in isothermal as compared to work in adiabatic, sign consider kiya to is the relation same?
No, reverse.
Obviously not, it will be reversed. So here, just look at the statement. The work done by an ideal gas in expanding V1 to V2 is higher when the expansion is done isothermally as compared to that carried out adiabatically. Have they mentioned
Oh,
the magnitude in the statement?
no,
Will that statement be correct?
no, sir.
No.
No. So B option गलत है. ठीक है. अब C. The internal energy of an ideal gas does not change in the isothermal process.
Yes, sir.
Of course. And the fraction of heat utilized in increasing energy of a monoatomic gas is 3/5 when the heat is supplied under constant pressure condition. Monoatomic gas. So how do you find the fraction of heat which is utilized?
QV.
Just use the relation.
QV is equal to MCV delta T.
QV is equal to N into CV into delta T. Now, heat which is utilized in increasing energy of a monoatomic gas. So, what do you know about that?
CV is 3 by 2
3
R.
by 2 R. And they are talking about the fraction of heat utilized. Matlab, you have to take a ratio. Ratio of what? Under constant pressure condition.
Yes, sir.
Constant pressure condition में क्या लेंगे? Q
QP.
P.
QP.
That's NCP delta T. And this will be
Yes, sir.
equal to N यहाँ पे रखते हैं. So, N into 5 by 2 R delta T. Take the
Yes,
ratio. What
sir.
do you get?
3 by 5.
3 by 5. Is it correct?
Yes, sir.
So answer will be option A, C, and D. 14th में the answer is given as AC, but it should be ACD. हाँ? And 15th में भी गड़बड़ है. It should be ACD, not ABCD. Because if you look at option A and B, both are given calories and both are said to be correct, which is not true. So 14 is ACD, 15 is also ACD. Okay.
Yes, sir. So in part A, I didn't understand what you do. The
Part
mixture part A,
A
14 by
वाला.
A. Hmm.
See, when you are mixing two gases which are having different atomicity, तो अगर दो gases को mix किया, let's say I am mixing oxygen and helium, ठीक है, तो इसका total molar capacity, heat capacity mixture का कैसे find करोगे?
Partial molar capacity.
हाँ, it's similar to the partial pressure concept, ना? Moles
Yes,
of
sir.
first into the actual heat capacity plus moles of
Yes,
second
sir.
into actual heat capacity divided by total moles.
Okay, sir. Yes,
So
sir.
if you see, it is mole fraction of first into CP1 plus mole fraction of second into CP2. बस वही फंडा लगा है.
Yes, sir.
Okay.
Yes, sir.
Next में 16th. Now simple है ये. O2 के लिए what is the possible match?
PQ
PQ, because gamma for a diatomic gas is 1.4,
1.5.
and Cp is 7/2 R, तो P and Q दोनों करेक्ट है. Into
PQ.
again PQ diatomic ही है. CO2 and methane. Now these are polyatomic gases.
Yes, sir.
तो ट्राई या ऊपर रहेगा तो गामा विल डिक्रीज ओवर देयर. So for that
RNS.
now R है कि नहीं है exact value 23/6 it comes out to be 3 point something. Normally the polyatomic gases का gamma is taken to be 1.33 and that is basically 4R/3R का ratio है ना. ये ट्राई है और ये पेंटा एटॉमिक गैस है, लेकिन गामा की वैल्यू 1.33 के बाद नहीं दिया है. तो Cp कितना है दैट वी कैन कंफर्म, बट गामा 1.33 या उससे लोअर हो सकता है. तो एक ही मैच हो पाएगा दैट इज एस. Cp उतना है कि नहीं है वी कांट कमेंट.
Yes, sir.
अब अगेन वी हैव 1 मोल O2 एंड 2 मोल O3. कैसे फाइंड करेंगे Cp को?
1 into 7/2R plus 2 into
ट्राई एटॉमिक.
try.
हाँ, 4R ना
Then try. Yeah, yes, sir.
ट्राई एटॉमिक के लिए. तो 7R plus 8R into 2, 7R plus 16R by 2, so it's 23R by 2. R by 2
Divided by 3, no?
divide by
3. Total number of moles.
अरे हाँ वो भूल गया. It's 23, हाँ 2 और टोटल मोल्स, तो 23R/6 क्या आता है. तो इसके लिए द मैच इज हाँ. ओके.
Yes, sir.
ओके. अब इंटीजर टाइप में सिंपल क्वेश्चंस है और कॉम्प्रिहेंशन में जो पैसेज 1 है दैट इज ऑलरेडी सॉल्व्ड इन 5.1. Q1 to Q4 and W1 to W4 values are given. याद है.
Yes, sir.
And passage 2 is about Kirchhoff's equation. So direct solving है उसका भी. 17th question you can cancel off. It's quite complicated. 17th. नहीं 17. नहीं 17 ठीक है, सॉरी. नहीं 5.6 is okay. ठीक है, that could be done. Okay, so solve the questions now. So आज का जो 5.5 and 5.6 था, the major part was about spontaneity of the reactions and the heat capacity CP/Cv concept for the different gases. बस उतना ही पार्ट इम्पोर्टेंट है. ठीक है. तो
Yes,
ओवरऑल
sir. Yes.
हाँ, ओवरऑल थर्मोडायनामिक्स में फॉर्मूला एप्लीकेशन विद द करेक्ट साइन. मैग्नीट्यूड वाइज तो आप आ जाओगे, लेकिन साइंस में मिस्टेक मत करना. दैट इज मोस्ट कॉमन एरर्स इन थर्मोडायनामिक क्वेश्चंस. या कांक्षी.
Is the 17th one cancel or no?
No, you can do it. Easy है.
Yes, sir. And so, but do I have advanced test every week?
हाँ, advanced test I have scheduled as see for this week